Welcome to Tech Talk by KPMG. Today we are gonna deep dive into the world of semiconductor. The semiconductor which run our mobile, our watches, our laptop, many things. It is said the country which will control the semiconductor will control the world. The chip is the new oil for the future. We are gonna look at the fundamental shift into the science behind the semiconductor. We are gonna look at the global capability centers. So with me I have Navin Bishnoi, the country head of Marvell India. Navin, welcome to the show. Navin, welcome to KPMG. And it's my pleasure to host you today. What we are going to do today is explore the world of semiconductor in a way which can make it a lot more relevant for the audience. And before we jump into the semiconductor, just let's rewind time a bit and let's understand how was your childhood, where have you grown up? Were there any initial influences of leadership which are still shaping your leadership style?
Thank you for hosting me. It's a good time to be in semiconductor. I'm glad to be here. And it's an interesting question. I'll rewind it, but let me ask you this way. You have met me for a while. What do you think, which personality I am, introvert or extrovert?
That's an interesting question. I think you are extrovert in the circle a lot.
Yes. So that's because of my role and the job. But as a personality, I have been a shy and an introvert since my childhood. Always, right? But I've been very fond of sports all my young childhood. I have grown up in the steel city called Bhilai. And I would say the best thing I remember about Bhilai was what you see Bangalore now. Bhilai was a cosmos city because it was created because of the steel plants. People from all over the India, for all religion, all ethnicity, all background, came in looking for a job and lived together and then have that community bonding and all.
The Maitri Park.
Right. So that's where I come from. And I think if I would have to connect the stories from childhood to now, and especially on my journey and leadership, two things plays out, right? And I think as a boy, most of us look up to our dad for the stories. My dad was working in one of the ancillary setup of the steel plant. And I saw him working very hard for the company and for the people around and all of that. And I used to ask him saying like, what do you get for being so loyal, so hardworking and all of that? And then he always told me is that I try to look at saying, what can I do for the company? And then on its own, company start doing things for me. Somehow that got ingrained into me that I'm not saying I'm not worked for many companies. I've changed jobs.
Right.
But whenever I've worked somewhere, I think that kind of remained with me, that do whatever it takes for the company and then it will come back to you in a bigger way so that you can keep doing more.
Interesting. And then you touch upon a very interesting point that you are at the right place at the right time. How did semiconductor happen to you?
Yeah, so semiconductor happened was, it's a two-step journey. The first step journey was that at 11th standard, when most of us want to go do IIT, right? Write the JEE exam, be the IIT student, and get into the world of engineering. And I was going through that. And while I was preparing for IIT, one of my teacher, he came and told me, and literally in Hindi, tera IIT mein nahi ho, right? He said that you will not get through in IIT. And when I asked him, he explained saying, what I meant is that you won't get through this year to get the best branch that you want. You would probably get in and maybe get the branch which you don't want or get the IIT which you don't prefer.
Okay.
Right? So there are two options. You take a break and next year you'll be able to crack through. Or secondly is that he explained me the concept of RECs, which is now an
Regional Engineering College.
Right?
Yeah.
And he said, you go to try for RECs and then you will get anything that you want.
Right.
And I just trusted him. And actually, I didn't write JEE. I just wrote the entrance test for RECs. And I got the 13th rank in the state. And I had every REC, every branch available for me to pick it up. And I could go pick electronics at Suratkal, which is both the number one college at that time for RECs, and electronics was the core engineering branch taking us into the future of digital. That was the first step that started. during the college, I think we all went through, it was semiconductor VLSI was not taught in 90s. So we were studying mostly electronics.
It was not even a subject.
It was not even a subject. TI had set up its shop in 85 in India, and they started hiring a lot of fresh talents from many of these colleges from the 90s. And so 98, TI came into my college, one of the dream company, first company. I got through on day one and then entered into TI, Bangalore Semiconductor entry by that. So it happened by just, I would say that some luck of chance and some thoughts of vision about electronics. And it's been 27 years doing that.
So after 27 years, if I say the world run on chip, is that a fair statement?
It is. And we are the superheroes of semiconductors that enable those chips.
And if you have to explain semiconductor to a 10-year-old boy, how will you explain semiconductor?
I would probably, I think there are a lot of things that we see around, right? The world is moving into a whole digital footprint, right? And I think the easiest and the foremost thing is still the cell phone that each one has its hands on.
Right.
And I think the example of what a cell phone can do, what was thought as a phone is actually a computer in itself to let you do all kind of things that you can do sitting anywhere in the world. Is built on what we call as the chips inside, which is built on the whole semiconductor materials, architectures and design. And that's changing the world. That's just the one, I would say, aspiration that people saw. And now changing everything, which is portable, handheld, and an powerful computer to make decisions, make life better for all of us.
While mobile is a very good example, and we all are using it on a day-to-day use, but we have had discussion about chip war by Chris Miller, which says chip is the oil of 21st century. How fair is that statement?
The reason it's fair, I will tell you, if you look at just India, right? India is growing into infrastructure. One is the whole physical infrastructure, right? We go around, you
highways, roads,
constructions, but not just the construction, smart cities, smart homes, smart manufacturing, smart factory, and all of them, right? And the second infrastructure is the whole digital infrastructure, right? And if you look at it, India is probably ahead of many countries in terms of enabling digital infrastructure, starting right from governance into the consumer and then into the enterprise segment, right? So with that whole digital infrastructure is enabled by the so-called as semiconductors and the chips and the like. All of this digital footprint need a compute power, need a connectivity, need storage elements, and then enable you the smartness or intelligence that you need to make things happen. Right. So it's the building blocks, it's the oil for the future.
And if we say, and if we go back to the reference of the same book again, and thanks for the book which you gifted me 2 months back, the chip war, the geopolitics, right, which is making it a lot more complex, plus adding the complexities which we saw during COVID, where the supply chain of not only semiconductor but every other product was challenged during the time of COVID. How this geopolitical scenario emerging for semiconductor?
Yes, I think what triggered was definitely COVID, right? And the reason I will tell you, if you have to look at any chip that gets used, right, the number of regions or geographical boundaries that it crosses is significant. It's not single digit, it is in multiple digit. That from where the design is coming from, materials, chemicals, gas, manufacturing, testing, packaging, it crosses boundaries. So COVID challenged that boundaries because of the physical, I would say, boundaries that countries had to create to stop the COVID. And then that started the challenge of the supply chain, that things were stuck, right? At the boundaries or at the ports. Once we got out of it, we had some of the supply challenges, it got solved, but that's where a lot of these geopolitical situations started. We are seeing wars, we are seeing cold wars, virtual wars, all of that is happening. And everyone realizes the future world may not be won just by the weapons or things.
Right.
It might be won by just having the right technology.
Right.
And you can control or you can drive things, right? And that's what you see when you realize the power that technology enables you with. Every country wants to say is that, can I be self-sufficient? Can I have my own destiny? Can I control the best-in-class technology? And that became a geopolitical tension saying, I'll do it all by myself. So that's still going on. The fact still remains, no one single geography or country can do it all by its own. Okay. There are too many components and too many things involved. So we'll have to still get out of that one boundary of a region or a country. But some of those things will continue to be the I would say driver of the technology and then be able to control the future that we want to see.
Where do you see India playing that role? Will India be able to make release Make in India chip sometime this year, next year?
Sure. So if you rewind a bit, India has been in the chip and semiconductor for 4 decades. 85 is when it started. And it's been 4 decades that we have been there. The only thing is that we've been way too focused on the design side of the chips or semiconductor, right? So you name a design company in the world, it has a big R&D or a development center in India. And the fact states that almost 20% or higher chip designers in the world are Indians.
Right.
And if you add the Indian origin chip designer across the world, probably it goes to much more higher. So the design space was well, I would say, covered and has grown significantly. What we were missing was that how do we manufacture these designs, right? And in post-manufacturing, how do we package it, test it, and then take it to a system and convert it into an end product. So what we see in the last few years is that we have started moving into the manufacturing space where government came to the front because there's a huge entry barrier. The capex investment is significantly high. So government came up with a very good scheme for incentives, the benefits, the right policies, and a red carpet was thrown to the global companies and Indian companies to come and be part of the semiconductor manufacturing. And we have seen the results. There are already formal announcements. There's already, again, dozen of projects which is under review, and there are more aspirations that gets talked about regularly as well.
Right.
So that will get us into the manufacturing piece. For silicon, maybe I would say, right, will be sometime next year. There are different dates that we hear. Both of us will follow the news to see that when it comes out. But what is also that needs to be done so that this whole ecosystem is complete is that how do we create those system and product companies who will use these wafers that we are manufacturing here, who will use these chips to put it into a system and then make an end product that you and I can use. Like whether it's a consumer products, whether it's those automotives, whether it's this enterprise applications or networking, whatever. So we still have a gap of those big
market
product system companies who can compete with the Koreans, the Chinese, the Americans, and Europe brands who put the final end product in our home, in our factory, in our office, or on our body.
A very important point which you nudged is since 1985, India has been part of the semiconductor design or research space. And today you see GCCs are playing a very, very critical role for many of these large fab and fabless companies. Despite of having the largest talent pool globally, where do you see India in the product ownership of the semiconductor?
Yeah, that's what I was trying to connect in the last point was that the product ownership is I would say at this time not at the same place where the way we support the GCCs or the way we are inviting the manufacturing footprints and coming in. We do have semiconductor startups, successful startups, which has been converted into a very successful exit, being acquired by Tata, being acquired by Renesas, being acquired by other companies. But these examples are few in nature. You can count it on your hand probably and be doing it. We need much more than that. And then we need, which is much bigger and into wider space. right? So government DLI scheme is promoting, saying, can we get the startups which is into chips and then into products,
Right.
which can get into these. So that is starting, and the whole vision is that we move from a dozen startup companies to 2 dozens, and then to maybe 100 or 200 startup companies. Right. So we are on the path for that, but we are still have a long way to go and be called as a product nation, and then creating the world class next generation product out of here.
And if I shift the gear from talent to technology, what we hear in the market is Moore's law is kind of bit of slowing down.
Yes.
The number of transistors on per unit, whatever was quoted, is not gonna be that significantly reduced further, because we are now talking about a single digit nanometer
Right.
kind of lithography capabilities. If that is the way we are heading to, what do you think will be the next wave of innovation in semiconductor? Where are we heading to? Are we heading to quantum? Are we heading to AI design chip? Where do you see this market 5 years from now?
Got it. Yeah, I'm glad you asked that, because I think if any discussion on semiconductor doesn't talk Moore's law and AI, right?
And any podcast today without AI.
We won't be complete, right? But see, I think the Moore's law kind of gave us a direction, right? Saying like, hey, every some frequency of 18 months, and then you can double the things or reduce it by half as you look at power, performance, area of a transistor and the chip, right? And I think we have been going very strong for many decades, and we have come from many microns into nanometers, and now we have reached to single digit nanometers. And next we are calling it angstroms, where we have started going to 1.8, 1.6, 18 angstrom, 16 angstrom, and below, right? There are two directions that's going forward from here.
Okay.
One, I think as we go down, it may not be at the same fast frequency, right? Secondly, when you go down, we will also look at saying what are the alternate methods or materials that we can do, right? So we created something called as a FinFET as we came down into the 14 nanometer and below. And now we have started looking at something called as a gate all around. So it's a new way to create a transistor and then continue growing down. The second one would be is that how do we represent a transistor or a logic operations through different ways, and you're seeing the quantums and other things coming in there.
Right.
The second side, what we saw is that all of this was two-dimensional in nature.
Right.
You had a chip which you said is that a horizontal versus the vertical, a dimension, and a some level of a height as you stack different transistors and logic aside. What we have started saying is that how can I stack and go 2.5D or 3D?
Okay.
On the same chip or next to it, can I place something, and then I can start placing something on top of it? Okay. It's like a Manhattan growth, right? When you ran out of so-called as an independent row houses, you started
building on top,
right? So that's called heterogeneous integration,
okay,
where you have started integrating the small pieces, the functional blocks on a particular, surface, and it can be next to each other and then stacked on each other.
It's very interesting. Are the fundamentals also shifting? Are we talking about instead of electrons, are we talking about opto also coming into picture?
It is. So I think we already saw that what was electrical started moving into the optics.
Right.
And
especially in data, right?
On the data side, because if you look at the data center and cloud, the XPUs of the world, where all the GPU, DPU, NPU, DPU fits in, right? They have gone into a TBPS speeds. The architecture to build the compute significantly gone up, but the networking didn't, I would say, grew as fast as possible. We were in the mix of copper, and then optics came in, and that pushed us in to increase the speed, reduce the power. And now we are seeing that optics, which was supposed to be in the long cable, which you connect between many regions, has started getting into the design data center and now into the racks itself, and getting into very close to where your processor or server is more, right? So yes, we have the already integration of electrical with optical happening very close to the chip, into the board, and into the overall system.
the AI wave, right, where we are talking about quite a lot about generative AI, which is a headwind and the tailwind both for the semiconductor industry. I wanted to understand from you: is AI helping you designing better chip? Is AI helping you designing self-learning hardware? Is AI impacting the core of the semiconductor business, which is design, R&D? Adjacencies we understand, customer support, chat, generative AI, but is the core also getting impacted with the advent of AI and the new powerful AI systems coming into the picture?
Yes, definitely, right? If you just zoom in into the design world when we do, right? So our assumption is that we have a set of technology, what we call as the transistors and their electrical and physical behaviors. And then we have a lot of EDA tools, which has been enabled to ensure that I have some automation to connect billions and trillions of these transistors and make this chip, right? Now, imagine me doing it by hand few decades back to using many of these EDA tools and doing it. And now it has gone to the scale of billions and trillion transistor, right? So definitely I need so called as an efficiency or smartness or automation in my design space. Right. So when we write a functional logic, it is also a kind of a coding.
And supported by AI.
Yes. And then we are trying to so-called as leverage AI saying, can I write some of the codes using AI
More efficient.
and then I can start, validating it and figure it out, does it cover anything? Similarly, when we go into the implementation, the data that I manage every day, managing these billions and trillions of transistors is humongous. How do I go to the right place where the real electrical problem is? Debugging, making the simulations faster, optimizing it for the best power and performance. That's where AI comes and play a huge role to enable do a quick data analysis based on multiple runs and comes and let me focus on where a human intervention is required for the final debugging, for the simulation analysis, for the optimization decision, for the best design outcome and all of that. So it's now day in part of my design world as well, all these AI technologies.
Oh, and if I take another step forward and say, if someone is in engineering college today, listening to you, and what we spoke is almost a rocket science.
Yes.
We are talking about quantum compute. We are talking about new material science. A graduate which is doing a 4-year graduation, right? Where should they focus? Should they direct jump into the what's and how of the quantum compute, or should they work on the fundamentals? How can today's talent be more relevant for the semiconductor industries of tomorrow?
Sure. I would suggest, right, the semiconductor right now is everyone's dream, right, to be part of, right? It wasn't the case for many years that I have been there, right? What we still see, a lot of people said when AI came, will a design engineer be needed? Absolutely. Many 20 years back, when EDA tools came in, people said, Navin, do you need a physical design engineer? Because EDA tool can do the automation and do everything. I'm still on the job. I still did design using EDA tools and made it better. So the AI is not taking away jobs, semiconductor jobs. The design jobs will be there, and it is still built on the foundation of what we call as the digital design or analog design, and it called as a VLSI design, depending on where your interest lies. And along with that, the problem solving capabilities, which is what is needed. Most of the time, what we do is solve a problem because we fed it into EDA tools, we fed into other simulation tools, and then it told us that this is what you thought and this is what it is, right? And then you figure it out where the gap is, right? So the problem solving skills along with the foundation of VLSI design is still I would say, the entry point. The challenge right now is that for a long time, most of the semiconductor companies didn't hire from bachelors, the undergraduates, because the exposure to LSI was really limited.
Yes.
So most of us said that, hey, we will hire masters because they've gone through another 2 years focused on VLSI, and then we hire them. Thankfully, AICT has introduced a VLSI program.
Right.
And even the other electronics program has VLSI courses in their third year and final year. That helps a lot of these people to also get it into the semiconductor.
So very good segue for the next one, India Semiconductor Mission.
Yes.
Is it gonna help India ecosystem to develop the talent as well, or what is India Semiconductor Mission?
Yeah, so India Semiconductor Mission, it has multiple things. So there is one is this whole policies and incentives and benefits,
Right.
so that we can complete the supply chain. We have all the entities, either Indian or multinationals, and ensure we have the supply chain to create. So that's one part of it, right? The second big part, which is on the talent side of things, and then what do we need talent for, right? All this while we have been focused and talking about talent needed to work in these corporates, in these companies, right? Which is needed, and we continue to grow, right? There are more and more chips that are being created to make this world better, and hence we need more engineers. And now we need engineers in the manufacturing place. So we need materials engineer, chemical engineer.
Do we have that talent?
We have that. We have that. Definitely. It's a good sign that those people have a semiconductor ecosystem to get absorbed as well. Otherwise, they were going into a other manufacturing there. But the other place where we need talent, which we don't talk about, but we have been starting to discuss, is that one, we need a talent to go back into our academia, because that's the building block for creating this talent, right? And we have been short of the right academia faculties who can teach these VLSI programs.
Right.
And third and most important, finally, this is what you called as a rocket science. There is a huge technology development that we need to do, and hence a lot of R&D focus, right? So you need to create a research ecosystem so that you can go and say, what is the next materials? What is the next devices? What is the next system integration? What is the next architecture, right? And do that research right there in the academia, supported by industry, and build a talent who is doing that to shape the next generation of semiconductor technologies and architecture.
So if we look at the value chain and we look at from the market demand led research, research led development, development led design, design led fab, and fab led, let's say, OSAT or go to market. Where do you think India is super strong, and where do you think we need to focus a lot more?
Yeah, so what we call as pre-silicon or before manufacturing, there are three spaces there. There's a whole design space where we are doing the chip design, but it is enabled by two verticals, what we call as the EDA, software for the semiconductor design, and then IPs, the building blocks that feeds into this design, so that we can plug the block together and do the design. This space is pretty matured. That's the reason I was saying that design has been strength.
Right.
Manufacturing is a problem that's being solved. Right? The gap that still exists is that creating the products and a system mindset, right? To ensure that we can build products which is needed for India and for the rest of the world right from here. That's a gap, and that still needs a lot of focus and improvement.
So the product ownership and the product design, the architect part is what we need to shift. What will be the few things which we should do as an industry or an ecosystem to bring in that mindset in India?
Yeah. So there are two ways we can solve it, right? First, let's look at, we have to create a product. And the product can be for two reasons. One, we want to replace a product that exists, which is coming from our neighboring countries or other areas. And we just say we will replace it by creating an indigenous product, and it can probably have a feature set which is fitting more for the India conditions and use cases. The second is a new product that we create because there's a new opportunity, new gap, and hence a new product opportunity exists, right? I think the first one is easy, where you can have a set of expertise that we have, do the analysis and do a replacement project.
Right.
What we need, and then that's happening in quite a place. What we need is the new product identification, architecture, and then doing the business analysis, feasibility analysis, and then be able to go do that. That's where we will need, and probably we didn't do much. It's a lot of Indian origin people who are doing that sitting in other geography. We had that brain drain, that the whole product architect, product management, and many of those people went to different geographies. One, because that's where the customer was. One, because there's where a lot of technology and IP creation was happening. And second, also the quality of life, all of that. But I think that's the reverse, I would say, brain drain or reverse that we are seeing. That we have the talent, the who's and who's of the world is coming back to be part of this.
Right.
And as we build this talent along with those experienced people, with our new generation entrepreneurs and the technologies, I think that's the gap that we need to fix. That's a lot of work that needs to be done.
So when do you see a truly Indian fabless company emerging on the horizon?
So again, we have to qualify that statement. We do have Indian fabless companies. We have to qualify saying a fabless companies having so and so revenue with a commercial. I think the question becomes is that who among them can get into a scale revenue on global, many $100 million to $1 billion, right? And I think there's a good start that also happening. Couple of big Indian large companies have invested to be a fabless companies. So combine these startups, combine these things, we are on a trajectory to have a large number of fabless companies with successful products, with a revenue which is decent, but going to a what we call as $1 billion is a long-term roadmap. And it is at least, I would say, 5 to 10 years away. And simply because, let me just tell you, is that a semiconductor chip design cycle is usually between 18 months to 24 months to 36 months.
Okay.
So it's a long production cycle. So it does not end. And so to get a revenue from ideation to revenue, it's a long cycle.
But the market leaders have been shrinking this cycle. Like earlier, it used to be 3 to 4 or 5 years. Now, every year, there is a demonstration of the new chip by many fabless leaders. They come every year on the stage. They demonstrate that within 1 year, they have impacted the parameters, they have impacted or they have created something which is new. Is the semiconductor life cycle shrinking that much that we will see innovation happening every quarter or every year, every 2 years?
For sure, the product cycle is shrinking, right? Because we have these automation and smartness and intelligence built into our so-called as day-to-day work and methodologies. But why you see, because we just saw, right? You see every year wait for this GTC,
right?
And then invent. And there are many such, right, platforms where there is a focus on every year announcing what's next. This is my next chip. This is my next product and all of that.
Below.
So what the point is happening is that the new product introduction is happening at every year. But can a product be done in a 1 year? No, just the manufacturing is 3 to 4 months. Imagine doing a design before and then the whole test and validation.
Right.
So what's happening is that we are doing a lot of concurrent development and a parallel development. So what got announced in a so-called as an event this year?
It might have started somewhere.
Started 3 years back.
It is part of one of the cohort.
What would announce next year is something which started 2 years back. And so there are 3 parallel streams coming in. One which is in close to production, second which is in implementation, third which is in so-called as an architecture or definition, and then fourth which is just ideation. So you have those 4 parallel streams running in to ensure that you're not missing out what is needed 4 years down the line, but also have something for what's needed today.
And then the fundamental shift in the science itself, which is going to disrupt quite a lot of this, which is like Google's Willow or Microsoft coming up with its own chip, which is enabling the quantum compute at a room temperature. Those are the fundamental shift in the science itself. Even some of the Indian startups are now aiming a moonshot of creating their own quantum computer of 25 qubit based in Bangalore. Where are those science shift are coming from? Are they coming from academia? Are they coming from industry? Or are they coming from the deep pocket valley companies who are investing multi-million dollars in these research and development?
Mix of all of that, right? And then same happened when we started bringing in the optics into these electrical of the semiconductor, right? Definitely the big guys are investing on what's
continuous
and what could be done. But a lot of the first one probably is a startup, somebody who believed that I don't need to go by what legacy was done. Created a proof of concept, academia built on that or kind of created a prototype, and then the big guys coming and owning over it. So I think quantum is one such example. that's coming out from this. There are startups. There's a huge research in academia. And then there are the big guys who are seeing is that, can I use it and can I commercialize it? Right. So it's definitely exciting. It's a long game to reach there, to commercialize it. But that would be the next wave probably after we settle down with AI, which is what we are currently
grappling with.
Yes.
So before you arrive, we reached out to our audience and we collected a couple of difficult questions for you.
Okay.
And now we are going to do the rapid fire round.
Okay.
And we'll start with, what is the biggest misconception about semiconductor?
That it's very tough to do.
Okay. One emerging technology that you are betting big on.
The connectivity and networking for the future data center.
One book you will recommend to every semiconductor professional.
Chip war.
Chip war. One piece of career advice for semiconductor professionals.
Have patience. Each product development is a long cycle. You will not see the end of the product in a month or in a year. It takes long, and then you should have patience and have the quality mindset to do it first time right.
If you had $100 million, which technology you will bet on?
Which technology I'll bet on? I will still bet on I would say what I said is the connectivity. Compute has been solved. Connectivity is what we need to enable to take it to wider reach to the masses.
Okay. I think with that we come to the conclusion of today's session. Any key takeaways for you which you would like to share with our audience in terms of if we have to collectively grow this ecosystem, what are the three things which we need to do as a community?
Right. Yeah. So I think three things, if I pick it up, as I said, we can create chips, we can do manufacturing. Finally, we should be able to buy those wafers and chips. So hence, we need to create a product/system mindset and an ecosystem to be ensured that we can leverage all of these and put a product that can be sold in the wider market. And then not just India market. We won't be successful doing just in India market. Yes, we do have the volume, but to be able to make it big, we need to target the whole global market. The second, the people talk about India as a talent factory. Well, yes, our population and the age of the population helps, but we need to go and move from talent for just doing the execution and implementation or following others' ideas into what we call as the research for the next generation. And that's what we need to focus on. And then third is that as we connect these two together, we need to ensure that we have more and more startups and ecosystem so that we connect all the pieces from IP to design to manufacturing to products and have an ecosystem which does a seamless, connection or collaboration of all of that and really leverage or enable the digital infrastructure growth that India is driving.
We looked at the complete value chain of the semiconductor, where India leads, where India needs more support. We also looked at some of the emerging trend, chip being the new oil, chip being the next wave for many countries, many emerging economies to focus. And we also took three key takeaways. One was on the product. Second was on building and having the patience to build the world-class product and also giving it a global scale from India, from Make in India. So if I go back to Chris Miller's statement where he said, whosoever controls a semiconductor will control the future. How close is it to the reality?
It is true already. If you look at the whole way the world is moving, everything is controlled by digital, right? And it is built on semiconductor, right? I think the statement saying one person or one country or one region will control may not be true because no one can do it. But yes, that would be the most powerful and most, I would say, forward growing technology instrument that one will have.
So for now, it will be the verticalized alignment globally, the countries coming together and making sure the supply chain and the value chain is complete within those set of countries. So there will be kind of different lobbies.
Yeah.
If you have to conclude today's discussion and conclude with that one word for the future of semiconductor, what will it be?
Smart.
Smart semiconductor. Perfect. With that, we come to our conclusion of the day. Thanks a lot, Navin, for coming over and talking to us. And we look forward for many more sessions with you.
Absolutely. My pleasure. Thank you very much.